carbohydrate, lactone formation.
Wait.
Carbohydrate, lactone formation.
Wait again.
Lactone formation, carbohydrate, lactone formation. Okay.
Good.
What is the lactone, Lisa?
I don't know.
You should know it because I tell it.
Can I just say it's a
Do you have
lactose with the ketone?
Lactone is cyclic ester. Lactone is what?
Cyclic ester.
Cyclic ester.
But is it a lactose with the ketone?
No,
like
no,
that's cyclic?
No. Lactose is a sugar disaccharide from the glucose and galactose. Lactone is a cyclic ester. When the acid make a reaction with alcohol, the ester is formed, yes? Ester plus water. Do you remember this one? No, this acid. What is the name of this compound? Can you tell me the name of this compound? 6 carbon, carboxyl, carbon 3 is left.
One.
No.
This is a glucose with carboxyl. This is a
Gluconic.
gluconic. Carboxyl with glucose. See this one? This is exactly like that. It's a gluconic acid. When it will be a cycle, again carbonyl make a reaction with that. But this is a lactone. That's very difficult to draw on the exam. I want to draw for you like this. You can draw it exactly like a glucose, as you know it. Okay, OH, and here is C double O here, and that's a CH2OH, OH, OH. What is the difference between this one and this one? This one, carbon number 1 has a OH. This one, carbon number 1, double O. And this is a ester. COO is ester. And this ester is in the cycle. Because of that, it's a lactone. This is a gluconic acid lactone. Why this is delta? As you know, this is a carbon alpha. This is carbon beta, then this is carbon gamma, and it will be a delta.
Okay.
Understand? It means the delta carbon make a reaction with
this
carbon
one will be
number.
delta, yeah?
No, this one. This is a delta. On the delta.
Where's the alpha then?
It's alpha.
Okay.
Beta. See, beta is number 3. Now, what is the name of this compound? 1, 2, 3, 4, 5, 6. With 2 carboxyl is a car. Is a glucaric acid. Now, what's happened? This carbon make a reaction with that. One of my students asked, Masa, why this one doesn't react with this? That's a very good question. Okay, but always first carbon make a reaction to one to the last. And this is carbon number 3. Yes, if it was on the right also there is no difference.
Is there a compound that is the other way like this, where it has this one on number?
Yes, we have, but you don't learn it now, okay? Now, this one, where is the blue? This one comes to that. And again lactone formation happens. I wanna draw it for you like this, see? 6-member ring, Aisha?
Yeah.
Carbon number 1 has a double O. This is not a CH2OH like this. This is again carboxylic acid, COOH. Carbon number 6 is a carboxyl, and this is a OH, OH, OH. Good. If you learn this one, that's enough.
Foot. I thought it was Leica. It was
This is my hands, my foot.
foot.
Good. Is it important? Yes. On the exam, one of my friends asked, Masa, if we forget D, what's happened? Nothing, but put for all of them D. On the cyclic form, always put D.
Why?
I write here. On the cyclic, because actually the L form doesn't make a cycle. On the cyclic forms.
Ew! What are you doing?
Of sugar.
Licking her ass.
Oh, please pay attention. Of sugars,
Yeah, we can pay attention. He's licking her butt, right?
D. What's this? Glucose. And Fehling test. Oh my god, what was the Fehling test?
I
Copper,
remember.
copper. You know, is it red?
This is good to identify what? Aldehyde.
Aldehyde and ketone.
Okay, aldehyde, to differentiate aldehyde from
Ketone.
ketone.
There were two. Or something else. There were another two.
See, this is the aldehyde group. First of all, this is cycle. It will be open to the open chain 4. Then, the Cooper 2. What was the color of the Cooper 2? Blue.
Blue, and it becomes like
And it will become Cooper 1, and Cooper 1 is
Red.
red. Now, this one, the aldehyde, the Cooper is reduced. It means the aldehyde could be oxidized to acid, ox. And glucose will be gluconic acid. Yeah?
No, carbohydrate.
Silver mirror test or Tolen test also happens by this method.
Yeah.
Again, you can write that's the glucose plus silver plus basic medium. It's produce silver plus gluconic acid, and this is the way you can differentiate aldehyde from fruit glucose from other ketones.
yes.
But on the exam, they ask you, do the ketones give a positive Fehling test? Exactly like that. The answer,
Why not?
the ketone are negative Fehling. The ketone, okay? But ketones are positive.
Why?
Why? The answer of the why. This is a fructose. Yes, do you accept that this is a fructose? 1, 2, 3, 4, 5, 6. Carbon number 3 is left, OH. This is a fructose. Tautomerization happens. Do you remember oxoenol tautomer? This is a oxo-N-diol tautomer. This double bond comes here, H comes here. It is a double bond and 2 OH. This is a N with diol, 2 times ol.
Okay.
Then, again, what's happened? It should back here. But it said, okay, why should I come back here? I can go to the upside. And this is a tautomerization between fructose and glucose. The aldose is produced. Again, if I put the Fehling here and here, both of them, it could be oxidized to double O, and it's a deoxo compound. And the aldehyde could oxidize to gluconic acid or aldonic acid. That's a gluconic acid. What should you know? They ask you this question. You should say the ketone are negative in Fehling, but ketones are positive because of tautomerization. Because of tautomerization. If you just know from these parts, that's very good. From these parts.
But ketones, because it's of a sugar and ketone.
Ketone is just C-double-O between 2 R. Like acetone. Yeah, without OH.
Okay.
Understand? Now I want to ask you, we can differentiate aldehyde from ketone by the helping of silver mirror test and Fehling test. How can I differentiate aldose from ketones? For sure there is such a reaction, special for them. But this is not a Fehling and silver mirror test. Good?
Skype.